So everyone is visible, right?
Yes. Please
Yeah, so
make it slideshow more, please.
Yeah, it is slideshow.
No. Slideshow mode is actually, you have to go click slideshow.
Yeah. So, as a organization institute is about me. So myself, Viruprakashaia KM. So I have a 9 years of experience in FPGA Design Engineer and RTL wise. So currently I am working in Sykatiya Technologies Private Limited, Bangalore. So today, agenda of your today's is design RTL flow, how to do the FPGAs using RTL, and what is an FPGAs and what is an FPGA architectures and features of FPGAs and why you use the FPGAs and how to choose the FPGAs and some of the RTL code designs and the styles of the RTL coding. And so you have a different ICs in the semiconductor like SOC, ASCII and FPGAs will differentiate what are these 2-3 ICs and how to select the FPGAs in a package. And also, if any queries, you can discuss on later. Okay. So first, you'll understand what is RTL design flow. So this is a very important flow to understand any engineers in a VLSI domain. So in the VLSI domain, you have to see some of the design flow, some of the steps to understand what are the next steps to we do and what you are in here. Okay, so basically there are 2 or 3 engineers will come on to do this any VLSI domains in any VLSI IC chip fabrications or manufacturing. For next is RTL design engineers and PD engineers as well as verification engineers is a very 3 roles important to do the any VLSI type out designs. So as RTL design engineers, so we have a very, you can say it is a front-end design engineer. So they will look at writing the RTL codes by using a different coding models like Verilog, VHDL, and system Verilog also we can use. And nowadays we can use from the MATLAB and Pythons, and some of the schematic also you can use. So what are the steps they are going to do by using the design flows? So let us see in the left side, you can see here RTL design engineers. What is the design flow they are going to look at this during our designs. First they will look at the design entry. So design entry is nothing but writing the codes. As I told, we may use in Verilog, VHDL, or if you are very familiar with or more interested in the logical designs in the digital system like NAND gating and NAND gating and maths and mathematics. So from that also you can make your schematic and you can convert that schematics into an RTL or VHDL codes, and also you can write your codes in a Verilog as well as VHDLs. Okay, so design entry, and the very first steps of in design flow of RTL is design entry. Design entry is something about writing your codes. It may be used a schematic diagram or in any code of methods. Once you've done this design in your any tool or applications, you will do the simulations. So simulations is nothing but the writing. After writing your codes, you will do the functional verifications of your logical system. Suppose you wrote in the design like a AND gate or AND gate. So AND gate will do the performance of the 2 inputs as well as 1 output. So you will just check that output as in working as per your requirement, right? That's called simulations. So simulations, you can check your timing diagram, input assigning the input values. Once you've done the simulations, the very important steps to do the synthesizing. So synthesizing is nothing but to convert your design or logical design or your code into a logical gate list. So it's called a net list. So net list is nothing but you are making all the codes to in a logical gates. So you may know that about what are the gates are there. So AND gate, OR gate, NAND gate, and NAND gate, and NOT gate, inverters, XOR gate, and all these gates will make it in a synthesizer format. So after writing the codes, you're going to do the synthesizing. In the synthesizing, you'll convert our codes into a logical gates. Okay. So after synthesizing, you will get your circuit diagrams. As circuit diagrams, you can see in the right side in the engineer's floor. So once you will do the design entry, you will go to the circuit designs. You can see here NAND gate and OR gate and OR are fabricated here. So this is converted to our design entry. Then you will go to the optimizations and routing and placing and mapping and floor mapping and everything you'll do then after synthesizing. So in the synthesizing, you can check your timing simulations also. Timing simulations is nothing but as per your requirement, the code will matching or not with respect to the timing analysis. Okay, so placing and routing and floor planning you will do for the PD engineers. These all steps will make it to optimize your as much as possible to the design. So in the design engineers, they will do in the front end respect to the codes as much as possible to the design as optimizations, but not possible more optimization in the codes because you have to do your logical operations and functionality do in the design. But in the physical engine, in the place and routing mapping, we can do the mapping. How it is means, suppose you have a two AND gate. So instead of using two AND gate, you can use a 3-input NAND gate is as one AND gate. Then you can reduce your area of your FPGA, right? So you can like that you can do the optimization in the place and route and floor planning methods. Okay. Next you will go to once you've done the synthesizing, then you'll go to the implementation, then you go to the programming to our FPGAs. If you have a target, if you have a hardware board, then you can go to the programming with respect to the code by downloading the SRAM or flash to your board. Okay, it may be using the serial cabling or parallel cabling. Then the front-end engineers, you can generally call it as front-end engineers or RTL design engineers. The back-end design engineers also, they will do the verification. That's verification as well as validations and physical design engineers. So they will also do some of the design flow. So all any codes or any designs and any projects, these are the steps to be considered for your design. Okay. So if you miss your synthesizing, you cannot go for the programming to the design. Okay. First, once you've done the design, you have to do the synthesizing. Once you've done the synthesizing, you try to do the mapping and place and routing with the optimization of your design. Then you go to the programming. If you are not doing any optimizations, then you will take the most memory in your FPGAs. Then your utilization FPGAs will take more time, and your design will take more time to your as per your requirements. Okay, it will get the system or any design will be slow. Okay, so optimization is very important part also. So in the PD engineers, so they will do the, as I told, so they will do the system specifications. So system specifications is nothing but suppose I have a suppose I have a customer requirements or any our requirements, then you should understand what is that. What specifications you have to do. So once you know the specification, then you can start your design. So I cannot simply blindly can do any designs, right? So you, as per your requirement, as per the customer, suppose as a company projects, so you will take the specification from the customers what they want. Then it's called as system specification. Once you know the specification, once you know the number of input and number of output, number of clocks and reset and all, then you will start your architectural designs. See, this architectural designs is nothing but, as I told, UDLR, VHDLR, schematic diagrams. Once the design is done, then you'll do the functional design and logical designs. That means that you'll writing all the designs in your code. Then you'll go to the synthesizing, that will convert in your circuit design format. Okay, in the logical gates. Okay, once you've done the physical engineers will come into a picture. So as much as they are plausible to do the partitioning, floor planning and placement, with the proper floor planning and placement only you can do the optimization, then you can reduce your area in FPGAs. And also they will do the clock tree synthesizing, signal routing and timing closures. Okay, so then you will go to the verification engineers. So physical verification and sign off and layout and processing. Once you've done the layout, then you go for the fabrications. In the fabrication is nothing but the manufacturing of your IC in the PCB board. So PCB board, it means printed circuit board. In the printed circuit board, you will fabricate your package and testing with your program in a target. So understood, right? This is a design flow. It is very important to understand all the engineers to what are the steps to be considered. This is a design flow, nothing but what are the steps to be considered. So if you miss your physical design, so you cannot go for the fabrications also because you are not do any placement and floor planning with the clock tree synthesizing. So clock tree synthesizing nothing but you are checking all the clocks. So suppose you have a number of clocks in your designs, you have to check with the matching with all the clocks and you will get the actual output with respect to the clock or not. Okay. So if you're missing means you will get errors or any warnings and all in your designs. So all these steps should be considered during your RTL as well as speed engineers and verification engineers. Okay, it may be in a FPGA or ASCII. Okay, I will explain later what is FPGA and ASCII and all. Okay. First, you will understand what is an FPGA. So, FPGA is nothing but a field programmable gate array. FPGA is a field programmable gate array. It forms a matrix of arrays. All the designs in the FPGA matrix make the arrays in a matrix format. Is so called gate array. Okay. So it is in a semiconductor device or IC. It is in a semiconductor IC. So use it for the digital logic designs, and nowadays we use for the analog circuits also. Okay, so analog circuits is nothing but doing some Fourier transform, FFT and DFTs and DSPs also. So you can nowadays it is possible. So in the earlier to use it for the only for the digital systems. Okay, nowadays it is possible to do the update as an analog circuits also, and it is used for the digital logic designs. FPGAs can be reprogrammed to be rigid applications or functionality requirement after manufacturing or fabrications. As we know that, so FPGAs, so what is advantages, big advantage of FPGAs other than other ICs or any CPLDs in earlier ICs, you can number of times you can reprogram. With your desired applications, you can make the changes in your applications or functionals, or you can erase your functions, and you can newly can do the functions, or you can modify, you can change any times in number of times. You can reprogram number of times your desired applications, but after manufacturing. So some of the ICs like ASCII and other ICs in the earlier environment, other IPs, the microcontrollers. Before you have to do the designs, based on your designs, you fabricate or manufacture VLCs. But the advantage of FPGAs using nowadays means after manufacture also you can do the your programming, and number of times also you can change, you can modify, you can erase. Everything is possible in the FPGAs. So called it is very important in nowadays. You need to use it in. Yeah, so understood that what is FPGAs. Now we'll go for the applications of FPGAs, where you are using the FPGAs. So nowadays in all the domains you are using the FPGAs like communications, medical, aerospace and defense, image processing, video processing, data center and automotives. The communications we are using for the very nowadays is for the FPGAs because of you can changes, you can modify, you can upgrade your communications. Like nowadays you're coming from the 5Gs, all the 5G networks using FPGAs. In Intel and other companies are working with using FPGAs only. They're doing the 5G network. And telecommunications also, and wireless communications, all are running with the FPGAs only. And medical, the novel medical equipments like X-rays and other scanning equipments and other all the equipments from the medical field also they are using for the FPGAs because of they can upgrade their equipments in the later and future life. Aerospace and defense also they're doing aerospace, and also because all are automotive and other applications coming in the smart lane now using the electromagnetic level. So they are using the nowadays in FPGAs rather than other IPCs, image processing and video processing. So everyone using the image processing nowadays using a CNNs and machine learning, ML and AI. So they are also using the FPGAs, making different real-time applications. It is very important to use the FPGAs. Data centers. So data centers means so you have a huge number of data to store in somewhere, means you are using the FPGAs as a memory. And automotives, as I told, all the vehicles coming in very smartly to upgrade all the FPGAs also they are using in the automotive field also. These are the applications of FPGAs. So why FPGAs are using, what are the features of FPGAs means, as I told, it is easily configurable, means it is easily can be programmed. So it is a programmable logic devices, PLD, and thousands of input and output pins I have you can available in the market. So you can use number of input and outputs like 1,000 up to 1,113 or Intel processors and other. You have 1,113 input output pins in a FPGAs. High speed with synchronous circuitry up to 50 50 megahertz. So you can use, as I told you, it is very high speed with the synchronous circuits. So synchronous circuit is nothing but you have a number of circuits, a number of external devices connected in FPGAs. It will synchronize with all the circuit with the 50 megahertz. So it is already nowadays FPGAs is coming in 100 mega FPGAs also. Some Vertex 7 and Attack 7 of Xilinx and Altera FPGAs and Lattice FPGAs nowadays coming up to 120 megahertz frequencies. So in world 50 megahertz, and earlier we are using only maximum is 50 megahertz because of already higher versions of speed or using means you're already 120 megahertz frequency FPGAs also you are getting in the market. So it will consumes very low power. Okay, so FPGAs are using very low power. Maximum of our FPGAs working up to 5 volts of DC. So 1.2 volts, 3.3 volts, and 5 volts also based on your requirements. Very less power consumptions for the FPGAs. So programmable at the job site to get required functions. So the job site is nothing. You can change your program in the anywhere, in any time. Okay, so as per your get requirement of your function. Okay, so programming at behavioral level. So you have a behavioral element. Once you know the behavioral of the circuit, and behavioral is nothing but the output will changes based on your input. This is called behavioral level programming. So based on your, if you know the only logic operations of your design, then also you can do your FPGA programming. Okay, these are some of the features of FPGAs. Other than that, it is very less in size and small in size, and it consumes very less power, and area wise also very good in FPGAs. Suppose I want to do any design or any projects, how to select in FPGAs or ASCII. So I want directly, you cannot go to any electrical shop. You can ask to give a one FPGA IC or any one FPGA board to the right. So you have to understand how to select an FPGAs in your design or any projects. Then only you can succeed your project. Then only you can succeed your design. Because you cannot go to any shop or any online board to just to give an FPGA means they will ask, right? If anything else, not only FPGAs and not only anything, any ASCII. So you can want to purchase or you want to take any one particular device as any computer and PC, even though you are purchasing your mobile also, you will see some of the features and what is your requirement. And also it is very important, right? So you cannot go to any shop or anywhere or in online also, you cannot do the search in mobile and you will get one mobile and you cannot go directly to book, right? So you will see as per your requirement, right? So selecting of FPGAs or ASCII or any devices is very important to succeed to achieve your project to successfully, right? So some of the GS like a cost, this cost is including a design cost. So how much cost to design? Suppose you are doing the project of some around 2 crore. So for the design engineers itself, you are giving the 50,000, 50 lakhs and something means. So it will be very last to your also, and all the tools. So nowadays tools is coming with the licensed tools. Okay, nowadays you can do the online synthesizing, but once you do any programming with FPGAs, you need some licensed tools, right? But licensed tools also you need to purchase from the vendors. Okay, we have different vendors in India, so I will explain that. So that's also a matter of the tools. So for that also you have to give the money. So based on your budget, you have to look at the design cost, tools, and per device cost. What is the one FPGA, how much FPGAs you need and how much cost per device cost also it will matter. So what are the interface need to be connected externally? So if you have interfacing with the external devices like the CPUs or any communication or any microcontrollers or stepper motor, any other applications you are doing. So what are the interface need to be considered? That also will matter. Suppose you are using SP and I2C, means it will require very less frequency. If your less frequency means it will take the less cost. Okay, so and if you're using Ethernet, PCI, and other higher speed connections, your board or FPGAs, so it will take more cost also. So interface, what are the interface also to be considered? Okay, to connect the external world. Understood? Next, IO standards. As I told, so FPGA is working in a different voltage levels, and what are the different methods to be considered in the fabrication means LV CMOS, HSTL, and LVDS. So LV CMOS is the method of low voltage CMOS technology, and high speed TL transistor logic voltage levels, and LVDS means low voltage differential signaling levels. These are the voltage level signaling for the to operate input output standards. These are the standards to operate an input output with the voltage levels. Okay, some of the IPs IO standards working with LV CMOS, and some of the IO standards working with HSTL and LVDS. These are the comes in the fabrication time of your voltage levels. Okay, and what frequency need to be running your designs? Suppose I have a very low frequency design around I need only 10 mega or I suppose I need to get only 10 megahertz frequency like a counter LED or any small 7-segment display. So why need to go for the purchasing of 50 megahertz frequency board, right? So what are the frequency to be run in your design also very matter. Suppose I am using so let us take it as a updated technology as a 5G technologies. So it we need a maximum 120 to 150 megahertz frequency design, right? So for that you need to look at on the board of FPGAs, right? Otherwise, if you are purchasing 10 megahertz frequency designs and you are going to do a dump to the 5G technologies, or you're doing any Ethernet applications, means you cannot dump or to the FPGAs, right? The frequency is also matter of designs. Next, resource utilization. So resource utilization means as I told, 120 megahertz frequencies means, so I cannot use fully 120 megahertz frequency fully. If you're using 120 frequency in all means, then our system will get slow. So if you are using 120 megahertz frequency, at least you purchase of your board with the 150 megahertz, because some space will be there for the future users will make up the speed of the FPGAs and power, how much power it consumes also it will end up. And sizes also. So size also very matter, because in the PCB you are designing very less size, and instead of that in PCB designs whole size will take for the FPGAs means. So where will fabricate or we will solve other boards, other applications like 7-segment or microcontroller, flash, buzzer, other ports also you have to make in your PCB boards, right? So size of our FPGAs also matters. And package or explain later how to select our FPGAs also. So these are the selections of FPGAs for your successful design or project. So what are the FPGA architecture is considered in any device? It's common and basic FPGA architecture. It consists of 3 logical blocks. One is interconnect wires, control logic blocks, and IO bank. So as I marked here, so all these are connected in here, right? Is called IO pins. So I called IO bank. So all here outside of the external, these IO pins are connected between the connecting with the external devices or external to the world. Anything, it may be a controller, it may be a CPU, or it may be 7-segment, it may be LCD, and it may be a Wi-Fi. Anything you can connect with these to input-output banks. And as I told, it's on the FPGA is fabricated in the matrix format. So all the logic operations is marked in a matrix format. Okay, so it is considered a matrix switches of matrices. Number of switches matrix is based on your FPGA selections. And configurable logic block, CLBs. So you can see here CLBs, configurable logic blocks. Okay. So I explained here that. Okay, so you can see here what is logic blocks and IO banks and programmable routing. So logic blocks is nothing but so it is an LUTs, lookup tables. So I think lookup tables you may heard about. So a lookup table is consists of 1 mux, add, and D flip flop. Okay, each LUTs have a 4 to 6 pins. So you can anywhere you may be asking in the interview also. It is a very important question also. How much input pins are available for the LUTs? Each LUT has a maximum 6 inputs, 4 to 6 inputs. Okay, so more than 6 inputs will not be available in any FPGAs for LUTs. Okay, each logic cluster consists of number of number of LUTs, and each LUT consists of a D flip-flop, adder, and a mux. So whatever your designs, based on your designs, so that it will convert it in a mux or in a D flip-flop and a adder. So you can see here logic plus consists of a number of muxes, and so number of muxes and D flip-flop and number of adders. Okay, so these called LUTs, each CLBs. So each CLBs have a number of LUTs. In the LUTs, you have a one adder, one D flip-flop, and a mux. Okay, so your all the designs is stored in these three format. Okay, it may be D flip-flop or it may be the mux. If you are in a combination circuit, means it will convert as an adders based on your logical designs after synthesizing. Okay, so the programming routers. So programming routers means it will route your design with the number of CLBs or LUTs. Suppose I have two CLBs, so your design is taking a number of LUTs, right? In the LUTs, it will match your programming routing with the cascaded signals by using the IO blocks, right? So you have IO blocks with the interconnection between the two CLBs and it will routing your design. See here, some of the marking is there. Our designs, it may be stored in these CLBs, in these three CLBs. Like this, you can understand your architecture. So each architecture, there is a common architecture to all the FPGAs. It may be all the FPGAs. Okay. So as I told, you have a number of different ICs in VLSI. So one is SOC, FPGA, and ASCII. So now we see just what is an FPGAs. So SOC is nothing but an external semiconductor device. It is fabricated is a system on chip. So system on chip is nothing but a SOC as a FPGA. So we can see here Altera SOC FPGAs, right? This contains of a ARM processor as well as the Altera FPGA. It's called a SOC FPGAs. Means it will do the processing operations also. So if you are using only FPGAs, you need an external your processor. Okay, so we want to do the processing operations with the FPGAs, you have to purchase an extra processors. So for you will go to the SOC purchasing, so you will get the both ARM processor as well as Altera. So just I am giving the Altera SOC here. It may be Xilinx SOCs or the Microsemi and anything. Altera is a very more and all anywhere using SOCs rather than Xilinx. So I mentioned here. So as I told, so it has an ARM processor. It may own not only ARM processor, any processors. Okay, and Altera FPGAs. So SOC is fabricated. One is SOC processor as well as FPGAs. It's called system on chip. Okay, so it includes processor as well as FPGAs. So FPGA is nothing but field programmable gate array. So examples of FPGAs is Xilinx FPGAs, Altera FPGAs, and Lattice Diamond FPGAs. Okay, and ASCII is SOC is nothing but a system on chip. Next one is ASCII. So ASCII is as you know, application specific integrated circuit. So in ASCII is different between FPGAs and ASCII is, so both are in semiconductor device, but difference is nothing but in ASCII used for the only particular application, particular specific one applications or any design. Okay, so you cannot reprogram the design in your ASCII chip. Okay, it is only for using only specific only one designs, and also if you will do the design first. Based on your design, our ASCII board or our project will design. Okay, first you will do your coding, then you go for the fabrications of your chip. Okay, first you will do the designs in ASCII, but in FPGAs we can fabricate first, then you can program number of times. Okay, and you can change your designs also. So ASCII example is microphones, earphones. So microphones and earphones you can use for the only for listening to music, right? So you cannot use earphones for other applications, no, right? So earphones you can use only for the listening your music. Okay, you can enjoy with your music, audio, maybe video. But other than that, any applications we can use microphones also. But you can give the example of SOC is nothing but your mobile phones. So mobile phones have a processor, inbuilt processor as well as a FPGAs with memory also it is there, and processing also, operations also take care of by your mobile phones, right? So your best example of SOC is your mobile phones, and FPGAs you can use anywhere in nowadays, as I told. And ASCII is your earphones is a very best example. So the common and very important example to the SOC, FPGA, and ASCII. Okay. So they may ask in the interview also for your academic, you will go for the interview also. They will definitely ask for the difference between SOC, FPGA, and ASCII. So some of the based on your projects, you are using FPGAs or the ASCII or SOC. Okay, so selection of FPGAs, ASCII, and SOC is same based on your cost, power, area, size, and your frequency, and your requirements. All are same for the selection of your device based on your project. So as I told, so SOC is a consists of a processor as well as FPGAs. So it is a SOC architecture. So SOC architecture has a consists of number of processors. Also application processor. So number of application processor, you have a number of application processor. You have one application processor 1, application processor 2, and level processor also you can call it as in these processors, and core processors, the other, and you have some L2 latches and timers, PCI, DAC, ADC, internal memory, DDR, controller, and bus interface to the world, and USB interface, PC, SP, and UART. So all this comes in SOC architecture only. I mean, it is an inbuilt all the processor as well as FPGA applications. Okay, it's called SOC architecture. So as I told, so as RTL engineers, writing the codes using the VHDL or Verilog is very important to know some of the steps to be considered. First, you will write a code in the combinational logic design. This will take in you can use the equations or truth table. It will capture the combinational circuit into a captural level and truth table level. Then it will convert in the circuits levels. Then it will do the number of possibility of sequential logic designs and make an FSM. Then we will do the RTL designs method to create a custom processor. So custom processor is nothing but using the inbuilt tool IP custom process. So you can do it by using the custom processor means you can reduce the size of your design. Okay, so by all these methods you can do your RTL designs. So I am given you a small example here by using the clock. One is a clock and another one is the one input, and from the clock it will go for to do some combinational logic operations here. From that combinational logic it will go for the again new state, go to the feedback to the clock, and it will get do some combinational logic and will get your output. So this is a very simple RTL design flow. So you will take the one as a clock, one input as a clock, another is one input. From the input and clock it will go some logical operations. From logical operations you will get your output. Okay. So all these steps will take care here in this picture only. So you have a number of RTL design methods. One is VHDL, Verilog, and system Verilog, and also you have more familiar with logical designs. You can do your in the circuit format also. Okay. So some of the steps or guidelines to be considered while writing the RTL codes. So you cannot go do the RTL codes simply, right? So it should be useful for any future as well as for the other persons also, right? So use the comments whenever writing any codes. So you try to make it in comment wise in each lines or any multiple also lines possible in Verilog and VHDL. So comment is nothing but to making your suppose I'm writing the codes of the AND gate. So make it in comments writing the codes in AND gate 2 inputs. Okay, then other unknown persons means but common persons also can understand by your code in comment wise. Okay, so suppose if you write a comment, so y is equal to a and b means so unknown persons or some common person cannot understand what is a and b, right? So it will think as a and b. But you write it in the comments, doing the logical operations comment operations of a and b means that we can understand by reading the comments. Okay, by the comments you can use for the each lines or multiple lines also possible in Verilog and VHDL also. Okay, so making the comments is very good engineer style of writing any codes. It may be not only the RTL coding, it may be the C coding or any software coding or any or hardware coding. It's very good practice to make comments in each lines or multiple lines, right? And use synchronous reset. So reset is very important in any design. So why reset is using means to impact your design's performance and area and power. So reset, whenever you are using the reset in your designs, it will performance make them very good. Okay, and area wise also to make optimization in the area, and it consumes a low power. It try to consume low power in your designs. Okay, so synchronous reset is nothing but it is synchronous with your clock. Okay, so clock and reset is very important in using the any circuits. Why we are using reset means, as I told, it will impact your design in performance. Once you struck in your designs or in your board during the operations, you can just give the reset means it will do the performance from the initial value. It will go for the initial value. Yeah, the initial value is nothing but a 0 value in your digital logic. Okay. So synchronous is nothing but it will synchronous with your reset as well as your designs. So there are two types of reset in RTL coding. One is synchronous reset, another one is asynchronous reset. In the asynchronous reset, it will not wait for any clock operations. Okay, so it will, once you give the reset in asynchronous method, so it will take what are the operations it going or not. It will not wait for any reset clock conditions. It will do the reset automatically. Hello. Yeah, so synchronous is a very good method to use in your reset values. Use clock and enable signals. So in your design setting, in any designs, use the clock and enable signals. These are the reset control signal, and the clock signals and enable signals are the control signals. So you may say this, you may think this is a reset or clock and enables instead of using the any clock control signals. These three is a very important used in your any coding. Okay, use FIFO operation and use finite state machines. So FIFO operation, finite state machines, it will nothing but to use in any designs, in a complex designs, by using the FIFO operations and finite state machines, you make your code in optimization methods. And you cannot means you can reduce the possibility of setup violations and overtime violations. Means metastability, or you can reduce the as much as possible of your clocking problems or timing problems in your designs. Okay, so if you are using a finite state machines or FIFO operations, so you cannot completely reduce, but some of the timing problems you can reduce by using the FIFO operation and finite state machine logics. Okay, so you pipelining method also. So if you're using the pipelining method also, you can do the performance very good in your code. So use else if else statements rather than case statements. So you are using some conditional operations in your code, if statement, else statement, arrest conditions and functions and task and all you're using. No, if else statement considering means it will convert into mux operation. If you're using the if statement only means it will convert in a latches. If else statement will convert in a flip-flops. Okay, so these are the important guidelines to writing the codes. Okay, comments is very important, and if else statement also very important. Pipelining method also is very important. Synchronous reset also very important. Clocking also very important in your designs. So next is, so just I mentioned here two codes in VHDL as well as Verila. It's a counter code. So as I told, so some of the points I told right now. So these are the considered in this code. So as I told, so I am using clock and reset in my design. So because of the performance will be due, because once the clock will start, then only our operation will start, right? So if your reset is high, that output will be 0, or output will be in the idle state. You can say generally in idle state. Once the reset is free, then our operations will start. Okay, so you are using two inputs as in clock and reset. It's still a counter code. It will count number of bits from 3 down to 0. 3 down to 0. 3 down to 0 is a 4-bit counter. It will count from 0 to 15. Okay, so I took a temporary signal value here for the storing temporarily with your output. If reset is equal to 1, then temp out will be 0. Else, if rising edge of the clock, every year rising of the clock, our counter will count with respect to with 1 output. Okay, and if so, I am using the if means you should be use the else conditions and if else conditions. If you're not using the else conditions, it will generate as a latch. So latch is a bad designing methodology. So if all the designs will be converted in as I told, so LUT is consists of flip-flops. So it will try to make their code in converting your flip-flop. If you're not using the else if statement here means that this will convert as a latches. So latches, and I think you may already studied about difference between latches and flip-flops. So latches is a level triggered circuit and flip-flop is a, what is flip-flop? So flip-flop is a edge triggered logic. Okay, so that's what you are using the anymore in flip-flops, not in latches. Okay, so that's what you're using in the FL statements here. Then you will go do the process. And process also very important. The process is nothing but it will start our operation from the process and it will end up to end process. Once you give the process, you will give the end process. Until and that it will wait for the end process. Otherwise, it will do the number of times your operations continuously. Okay, so all the input values should be mentioned in a sensitive list. It is then you can all the process will do until unless you give the end values. Once you do the process, if not given the end process, means it continuously do the these counting operations continuously without infinite, because you're not ended with your processing operations. Okay, so process is also very important in your designs. So in Verilog, you are using here model count, clock, and count output. As I told you, clock and reset as an input and output is a register. So here you can see the two signals, wire and results. So wires is the interconnection between the any devices or models, and bridge is a temporary storing of your data. So I'm using it always at positive edge of the clock, as I told. So in the with respect to the positive edge of the clock, our counting will start. So if it reset means that if reset is high, then our counter will be in idle state or in 0 conditions. If reset is free, if reset is 0, then our counter will start counting with respect to the positive of the clock and end model. We're using an if statement here, so you're using end here. Otherwise, it will continuously counting with respect to if statements. So this is an VHDL and Verilog. You can see here the difference between VHDL and Verilog. So in VHDL and Verilog is nothing but, so here